Okay, everybody, welcome. Hope you're doing well. The substitute should have passed out the Unit 6 assignment sheet. I know you're probably curious about this stuff, but I want to make sure, no freaking out. You're going to have a 10-question eCart review for each of the units of study that we've had in order to help prepare you for your midterm. So we'll go ahead and we'll look down and see what we're talking about with our midterm. Your midterm exam is going to be on February 16th and 17th, and it's going to be in class. We're going to have 1 day of review, and then notice each night over the next couple weeks, you're going to have some midterm eCart reviews for you to work on to get your brain back into some of the things that we've done together. Now, you'll get the most out of these midterm eCart reviews if you page through your notebook first. If you refresh yourself with the things that we did, just paging through, taking a glance at each of the units, they will definitely make more sense to you. Of course, we'll talk about this more, but I want you to know that you have an infinite number of tries for these eCarts, so hopefully you'll end up getting that 10 out of 10 because it's going to represent a quiz score for the third quarter. We're going to combine each of your scores and then represent that as a quiz score. So if you're looking for a good quiz score, this is going to be an area where you're going to want to explore. All right. So today you're going to talk about ratio and proportion, and when I see you next week, we'll talk about similar polygons. We have our cell day, it's our religious observance day, and then we have this extra day for our black. I think what we're going to do is we're going to have some catching up to do because black, I know that you haven't had class as much. So we're going to touch base and make sure that our black days are well covered. For everybody, there's going to be this quiz on February 2nd and 3rd, another lesson on proportions and triangles, a review day, and then your test for Unit 6 is on this day. A day of review, and then the exam. So make note of any questions you have and be sure to ask me when I see you again. Okay, so we're going to start our Unit 6 with this skills review, reminding us how to go ahead and solve for proportions. When you have an x in the denominator, you have a couple choices of how you want to go about doing this. You can multiply each side by x, and then you have 4 is equal to 10x divided by 15. You could multiply each side by 15 to make these values cancel out. Then you'd have 10x is equal to 60, and then coming over here, you know, of course, then if you divide each side by 10, x is then equal to 6. That's the long way of going about doing it. Multiplying each side by x will make these x's cancel out. Multiplying this side by 15 will make these 15s cancel out. But notice it takes us a while. It takes us an extra step to make that happen. What we can do instead, I know a lot of you learned this as the butterfly method. We prefer to call it cross products, but if you prefer to think about the butterfly, then that's your choice. 7 times x is 7x. 12 times 5, of course, we know is 60, so our x is going to be equal to 67ths for this one. Now, if you think back to those cross products, you actually did end up having 4 times 15, which was 60, and 10 times x, which was 10x. So this first part of the problem we could have eliminated by using cross products. So we're going to call that cross products. It's a shortcut that we can use. The math is justified here, but we can go ahead and know that these products are going to be equal to these products. X times x, x squared, 3 times 12, 36. When I go to solve for a square, I'm going to take the square root of each side. So x is going to be equal to plus or minus 6, because both a positive or a negative 6 when squared is going to give me 36. We need to make sure we keep track of that plus or minus. If I have an algebraic expression in my numerator or my denominator, I need to protect it with the parentheses, so that when I multiply, I'm going to have to use my distributive property. That distributive property, x squared plus 3x is equal to 40, might end up giving me a quadratic that I need to solve. When I solve a quadratic, I'm going to make sure that I set everything equal to 0. X squared plus 3x minus 40 is equal to 0. I solve a quadratic by factoring and then setting those factors equal to 0. I'm going to split my x's. I know that 40 is 8 times 5. 8 times 5 are 3 apart. So I know that plus 8 and minus 5 are my factors. X plus 8 could be equal to 0. X minus 5 could be equal to 0. So x is going to have two values, negative 8 and 5. Now, if you don't remember this from Algebra 1, take a deep breath and don't panic. We'll continue going over it. But we want to make sure that you understand a couple things. When you have a quadratic, you set it equal to 0 to solve, and you factor, and then set each of those factors equal to 0. All right, let's check out this one. When I use my cross products, I get 5 times x plus 2, and I get 2 times 4 is 8. So 5x plus 10 is equal to 8. 5x is equal to negative 2. X is equal to negative 2 divided by 5. For this one, I again am going to have a quadratic. 2x squared is going to be equal to 5 times 10 is 50, divide by 2. So my x squared is equal to 25. When I go to take the square root of each side, x can equal plus or minus 5. So here's the things we want you to take away from this quick little review. Cross products is justified mathematically. It's a shortcut. When you get a square, your next step is going to be to take the square root of each side. If you get a quadratic, you need to set that equal to 0 to solve. All algebraic expressions need to be wrapped up in the parentheses, and then you're going to need to use the distributive property. All right, so here's some ratios for you. We're going to be starting to talk about ratios, and what we need to recognize is if that cross products philosophy is true, then I know that 5x is equal to 4y. So check it out. I can rearrange each of these so that I can have these same cross products. Do you see 4y here? Do you see 5x here? Do you see 5x here? If we want these to all be true, they're not going to have the same relationship, but they're all going to have a true relationship. So 4 times y has to equal to what? Yep, 5 times x. 5 times x has to be equal to what? 4 times y. 5 times x has to be equal to 4 times y. Now, if this is a little confusing for you and you want to know what I mean about a true relationship and not necessarily the same relationship, stick some numbers that you know are true. you know that 1/2 is the same as 2/4. And you know that cross products 1 times 4 is equal to 2 times 2. If you switched those around, you could have said 2 over 1 is equal to 4 over 2. Notice you still get 1 times 4 is equal to 2 times 2, but everybody knows 1/2 and 2 are not the same value. All right, so we did that. We proved our cross products. Here's some more radicals for you to practice. Something for you to consider is go on the hunt for perfect squares. Your perfect squares are 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, and 14 squared. All right, 15 squared. All of these are your friendly numbers, and you need to go on the hunt for them. When I look at 125, I know that breaks down into 5 25s. 25 is a perfect square. So if I had 25 times 5, this perfect square can come out of the radical. So 5 roots of 5 is my simplified value. Now this is what's really cool. When these numbers are already split into their factors, go ahead and continue to break them down. 15 is 3 times 5. 20 is 5 times 4. Now check it out. Here's a double factor. They can come out as 1. Here's a perfect square. I can take the square root of that. This 3 is what's left behind. So I'm left with 10 roots of 3 as my simplified value. Same thing here. And I'm going to go looking for values that I can simplify. So I know 30 is 10 times 3, and I know 12 is 3 times 4. Here's a perfect square. Here's a double factor. So the double factors come out as 1, 3. The perfect square, take the square root, and there's what's left inside. So my final answer is 6 roots of 10. Now when I have radicals with coefficients in the front, I can use the commutative property and to rearrange these. So I can call this 2 times 3 times the square root of 6 times the square root of 3. Anything that is in the same radical, if they are the square root, I can put them together under one radical sign. So I can call this 6 times the square root of 6 times 3. I know 6 is 3 times 2. Here's a double factor. They're coming out. So I can simplify this to 6 times 3 is 18 roots of 2. Same thing here. 5 times 2 is 10. 8 times 2 is going to be under the same radical. I know this is 16. The square root of 16 is 4. So that's how I end up with 40. 3 times 3 under the radical sign, 2 times 2 times 3. Notice I rewrote 6 as 2 times 3 because that helped me find my double factor that can come out of the radical sign. So 3 times 3 is 9, times 2 is 18, 18 roots of 3. So here's what's interesting. This radical sign is an order of operations. I need to simplify what I can. I can't take the square root of this and add it to the square root of this because order of operations says I need to simplify that first. So what I'm doing now is taking the square root of 100. Oh, that's easy. It's 10. If you had tried to do 6 plus 8, notice you would have had 14, and that would not be right. This becomes the square root of 32. 32 is 4 times 8. 8 is 4 times 2. Here's my double factor. So 4 comes out and 2 is left inside. Now I'm back to having my multiplication sign. So then this is something that I can break down. I know that 105 is going to be 21 times 5. So this is 5 times 21. This 120 is 12 times 10. 12 is 4 times 3. 10 is 2 times 5. Here's my 5 times 3 times 7. So what I did here is I broke each of these down into factors that I could then continue to look for double factors or perfect squares. Here's a perfect square. He's coming out as 2. Here's a double factor. He's coming out as a 5. Here's another double factor. He's coming out as a 3. This 2 and this 7 is what's left, so they stay under the radical. When I go to simplify that, I've got 2 times 5 is 10, times 3 is 30. And under the radical sign is 14. Now here's an interesting one for you. One of our properties of radicals says that you're allowed to take a quotient and put it under the same radical sign. So that's going to be a nice one for you, because if you notice 147 divided by 3 is equal to 49, so you can simplify this fraction and ask yourself, hey, I know the square root of 49. Look, that's one of my friendly numbers. So that's going to be 7. Notice I'm not doing any plus or minuses, because if the radical is already drawn, I'm not looking for any values of x. I don't need the plus or minus. I'm just looking for the positive root. All right, here's a big no-no. We're not allowed to have the radical in the denominator. So we do a process called rationalizing it. And when we rationalize it, we're going to multiply it by a form of 1. Root 9 over root 9 is equal to 1. So what you'll notice is I'm not changing the value of this fraction, but notice I'm giving the double factor that this guy needs. So I end up with 9 roots of 9 over 9, because the square root of something times itself. And then notice that this cancels out, and then I'm left with the square root of 9, which of course is 3. Now that I look back at it, I could have simplified this. Oh, I missed it. I could have called that 9 over 3 and called that 3. Either way, I get the same answer. All right, let's talk about this one. The square root of 20. 20 is 4 times 5. That's a perfect square. So he comes out of the radical as a 2 roots of 5. Now this one I do need to rationalize. So I'm going to multiply it by square root of 5 over the square root of 5. Here's what that's going to do. It's going to give me 5 times the square root of 5 over, here's my double factor. So this just becomes 2 times 5. When I go to simplify this fraction, these 5's cancel out. Square root of 5 over 2. All right, take a deep breath and go back and check out those radicals and see if they make sense to you. All right, so next up, we're going to work on simplifying ratios. A ratio is any time that we are comparing two numbers through division. And here we have this division symbol. And what I want to do, and the better you are with your math facts, the easier this would be. When I look at 48 and 60, I know they both have a common factor of 12. So I know that I can simplify this. 48 divided by 12 is 4. 60 divided by 12 is 4/5. So I know I can do that. Hey, here's a calculator trick for you. If you struggle with these, you need to be able to express these fractions in simplest form. So watch this calculator trick. 48 divided by 60. This is a little mini division problem, same as that. And I end up with a decimal. If you go to this key here that says math, and this choice here, number 1, that says fraction, and then press enter, it will simplify the fraction for you. So that's going to be a huge helper to some of you that struggle with fractions. So we can try it with this fraction. Now I know I can take a 5 out of this, and I know that I'm going to end up with 9/7. If you need to do 45 divided by 35, you get this long decimal number, and you do math, and then choose frac, and press enter, and it'll give you your fraction answer. So I want you to pay attention to the difference between these ones that with no units and these ones with units, and those ones, the units don't match. So what you need to do is you need to multiply it by a conversion factor that is equal to 1. So your conversion factor is always equal to 1. So for example, I'll show you how this works. I have 30 minutes and 3 hours. Do not think that this is equal to 10, because it's not. When I go to simplify, I know for every 1 hour, there's 60 minutes. Now sometimes kids say, how did you know to put the 60 minutes in the denominator instead of the numerator? Because I want my units to cancel out. Because I want this simplified ratio to not be dependent on my units. So when I put this through the calculator, I've got 30 minutes, and that's going to be divided by my 3 times 60. Remember, multiplying fractions is no problem. Top times top, bottom times bottom. Math, frac, enter, and I get a value of 1/6. So this simplified value is not 10, but it's 1/6 because these units need to be simplified. All right, let's talk about this one, meters and kilometers. My conversion factor is I know that there are 1,000 meters in 1 kilometer. And I know that this 1,000 has to be down low because this kilometers and this kilometers needs to cancel. This meters and this meters need to cancel. So when I go to do my calculator work, I know that I have 72 divided by parentheses. Now make sure that you know that these two have to be multiplied. 1.5 times 1,000. This order of operations is going to guarantee that this operation happens first and then the division. Math frac helps me put it into a fraction. 6 out of 125. All right, if I have 9 yards and 15 feet, what's my conversion factor? Put your units in first if you need to, because you need feet and feet to cancel out, and you need yards and yards to cancel out. I know that there's 3 feet in every 1 yard. Now, hopefully you don't need the calculator to do this one, because you know that multiplying fractions is no problem, top times top, bottom times bottom. But you can cross cancel if you know that there are friendly numbers. 3 goes into 15 5 times. So I'm left with 9/5 is my value, my simplified ratio value. Now here we have 5 miles and 6,200 feet. So I need to know how many feet are in 1 mile. And I have this silly little joke up here. This kid says, hey, to convert from miles to feet, you just remember 5 tomatoes. Because for every 1 mile, there's 5,280, 5,280 feet in 1 mile. Here she says to convert from kilometers to meters, you just have to remember 1,000 because our system, yeah, you get the rest. Pretty funny. All right, so now I have this conversion factor. I'm going to go ahead and use my calculator, and I'm going to say, hey, what is 5 times 5,280? And I want to divide that by 6,200, and I get this lovely fraction, math, frac, enter, and it's 132 over 31. So 132 over 31. And there's no units necessarily involved here. It's just a simplified ratio because we've removed what those units do. All right, next up, find the ratio of the girls to boys in each class. If I have 15 boys and 28 students, you know that that means I have 13 girls because 15 plus 13 is equal to 28. So when I'm expressing that relationship as a ratio of girls to boys, I'm going to say 15 to 13, and I'm going to write it using a colon because it's a part-to-part ratio, and that makes more sense. All right, if I have 12 girls and 27 students, that means that I have 15 boys when I subtract 12 from 27. So the ratio of girls to boys is going to be 12 to 15. And for this one, if I want to simplify it, I can divide each side by 3, and that makes 4 to 5. 20 students, 8 boys. That means that I have 12 girls. So when we talk about the ratio of girls to boys, 12 is going to come first. And again, if I want to, I can simplify that and call that 3 to 2. Those numbers are friendlier, so then sometimes they're easier. All right, so if the quadratic, factoring, and equation solving kind of blew your mind, we're going to come back to this when we're in Stinger together. So we're going to hold on to this and say, wait until Stinger, because we're going to go over. Now, if you want to remember your Algebra 1 and go back and factor and see what you can do and solve, go ahead, because you're going to need to know it. So go ahead and go get that knowledge now if you want to. Thanks for listening.